Alright, this is lesson 80, sum of a finite geometric series. We're talking about arithmetic and geometric. The difference is a common difference versus a common ratio. So we're talking about geometric today, so we're talking about common ratios being multiplied. And then there are sequence and series. A sequence is just a sequence of numbers. And a series is taking those numbers and adding them together. So we're talking about geometric series. So we're going to be adding those together. Alright? We talk about geometric series a lot in nature. Here's some examples of geometric series. Okay, so for example, this is a shell that's been cut in half. You can see that the compartments are getting larger and larger, and there's a common ratio. Each compartment looks exactly the same or congruent, right? But it's being multiplied by a common ratio, and it gets larger and larger, okay? And we can see that here. You could actually map that out. Or another example, you could see the patterns in sunflower.
Looks like active.
What's that? Looks like active?
Yeah, that bottom one.
Yeah?
Yeah.
Yeah. Cool. So, if you got art, you could use the same concepts from geometric sequences and series in art. So, you might be a scientist and you might want to study a certain animal, a mollusk. A mollusk lives in here, right? So you might say, how big is the mollusk? You might be studying it and you might say, you might need to figure out how much volume did this thing take. Okay, anyways, those are the examples of how it applies. Let's talk about how to do it. So the next step is the next slide are the steps. This is a formula you should memorize, so rewrite it over and over. If you're on the video, pause. Okay, here we go. I'm going to start talking about how to do this. So we want to figure out what is the addition problem for this series, and it's a geometric series. We got 3 plus 9 plus 27 plus 81. What if there are 9 total numbers? We added them all together, okay? So there's an easy way to do this. Instead of writing them all out, we use the formula, which is as follows. We write the formula out, which is S sub n is equal to a sub 1 times the quantity of 1 minus the ratio to the nth power all over 1 minus r. Okay? On this particular example, we need to find 3 different elements. We need a sub 1. So our a sub 1 is 3. We need to know a common ratio. We need to ask ourselves, is there a common ratio? 3 times 3 is equal to 9. 9 times 3 is equal to 27. 27 times 3 is equal to 81. Right? So our common ratio, or our r, is equal to 3. And then the particular term that this series will go to is to the 9th term, so that's given. So we just plug in our numbers. Whenever we see any of these letters, we replace them. So s sub n would be s sub 9. Which is equal to a sub 1, which is 3. That looks really messy. I'll fix that. 3 times the quantity of 1 minus our ratio of 3 to the 9th power all over 1 minus r, which is 1 minus 3. Okay? And then you pull out your calculator and start working it out. So it's 1 minus 19,683 all times 3 minus 2. And then if I were to subtract that amount, you just have a negative number with a smaller absolute value. So it's going to be negative 19,682 all over negative 2. And then we go back to your calculator and that's your answer, okay? So again, what did I do to find the value of this series? First thing I did is I figured out what my a sub 1 was, figured out what my common ratio was, and then what the term was that we're going to go to. So if I were to add 9 terms into this series, then I would find that answer. Wrote down my formula. As a math student, I always wrote down the formula on every problem until I memorized it. because it helps you memorize it. And then I replaced each of the variables with the actual number, and then I used PEMDAS to solve, okay? So you have to work out the parentheses with the exponents first, then the subtraction problem inside the parentheses, then you multiply 3 times the value all over -2, and you get your answer, okay? That means that the value of this is this amount. So this could be an example of the seashell, right? You could say the smallest compartment is 3 cubic millimeters, okay? Real small. The next compartment is 3 times bigger, it's 9 cubic millimeters. And you might say there are 9 iterations of the pattern going around the seashell. There's 9 compartments, 9 iterations. So you would say, how big is the whole seashell? Well, you could say it's not 29,523 cubic millimeters. Okay? You might say, and you might be studying the mollusk, and you say, oh, that's the size of the mollusk. Right? That's number 1. Watch me do number 2 now. Number 2 looks a little bit different. It goes plus, minus, okay? So that's kind of weird. I'll explain an example of that when we're done with this one. But it's the same steps. We take our first one, a sub 1. 2 is going to be our a sub 1. And common ratio, I know that I'm multiplying by -2 here, and then I'm doing multiplying by -2 again, multiplying by -2 again, and so forth. So that means our ratio is going to be -2 in this example, and n is equal to 7. All right. On this example, I'm going to take write down my formula again. S sub n is equal to a sub 1 times the quantity of 1 minus r to the nth power all over 1 minus r. Substituting first, s sub n, so it's s sub 7, or the sum of 7 terms in the sequence will be the first term, 2 times the quantity of 1 minus, and look what I'm going to do. R is a negative number, so I'm going to put -2 into its own parentheses, all to the 7th power, all over 1 minus r, or 1 minus -2. And I'm putting -2 in its own parentheses, right? So be careful in this one. I gave you this example because you're noticing that you have negatives in parentheses. So start with -2 to the 7th power. Okay, which isn't a big number like number 1. Can someone predict why is this not a big number like number 1? Yeah. Goes from negative to positive, right? Y'all seen that? You got a big number, or you got 2, a positive number, then it swings back to a negative number, then it swings back to a positive number. Can someone predict an example in real life where there might be something that's positive and negative and positive and negative? A stock, maybe, yeah. That could, if it's volatile. What else? What? I heard someone over here. Okay, what about a sound wave? Okay, sound waves come to you, and when your sound wave starts, like if it's perfectly silent, there's no sound waves in the room. There aren't any movements of molecules, but when there's a sound wave in the room, it starts off very small, and then it doubles, and it keeps increasing its amplitude until it gets to its greatest amplitude that it's going to get to. So this could be an example of like what the sound pressure is of that sound wave, okay? And there is sound pressure. You know, when you feel the music, you ever gone to a concert and you're close to the speakers and you could feel the music, the bass, and you're like, boom, you can feel it in your chest? That's because there's like sound pressure, right? The waves and the molecules are hitting you with high SPLs, and this might be an example of how they calculate that. Okay? Anyways, that's the example, or a couple of examples. So today's Monday. Let's have 1 Stella 2s about how we calculated the sum. And then 2 Stella 1s, how we calculated sum of number 2. Ready, set, go. Okay, number 3, let's do a couple together so that we know what we're doing for later. So we got 3, 6, 12, 24. So the first thing we want to do, just verify what's the first term. A sub 1 is, everyone?
3.
It's 3, right? Good, what's our ratio?
2.
2, right? Because each of these, you can see they're being multiplied by 2 in each case. Okay, good. And then what's n?
6.
6. Okay, obviously it's there. So write down the whole formula. S sub n is equal to a sub 1 times the quantity of 1 minus r to the nth power all over 1 minus r. And then we're substituting. We've got a sub 1 is 3 times the quantity of 1 minus r, which is 2, to the nth power or to the 6th power, all over 1 minus r, or 1 minus 2. So it's 1 minus 64 is negative 63 times 3, all over 1 minus 2 is negative 1. Okay? Finish up your problem, please, and show me your answers on your iPads. Ready, set, go. So if you made a mistake, fix it, okay? The calculator is only as smart as its user. It's hard advice, but that's what my math teacher used to say. So if you're not getting it right, practice the skill. That's why we're doing a lot of calculator work. You need to know how to use your calculator, because in real life, it's not about doing it paper and pencil. You're just using a calculator. You're using the tools around you. Okay, so let me prove to you that this actually works. What if we were to add these, okay? 3, 6, 12, 24. What are the next two terms after 24? Plus what?
48.
Plus 48. And the next one?
96.
Plus 96. Okay, let's all add these together, please. Shh, on your calculator. Just add 3 plus 6 plus 12 plus 24 plus 48 plus 96. Tell me what you get on your calculator. What's your answer when you add those together? 189, right? Wasn't that our answer? So which is easier, to add them all together or to go through the formula? The formula. Maybe this one, maybe you could add it, okay? But look at number 4. You can, but it's just going to take more work. So let's use the formula. This one's by yourself, okay? So you got 3, 18, 108, 648. And we want to know what's the sum of the values for the 7 terms in this series. Ready, set, go. Okay, most of you got this. It's 167,961. So it sounds like you guys are all getting it. So I am done with the lesson, and you are too.